The Hyperloop is trying to go down a tube really quickly. Even though most of the air is taken out of the tube, it starts pushing a column of air in front of it.
When the pod is moving within the near vacuum tube, there's a column of air right in front of the pod. So what the compressor does is that it takes that column of air and it moves it through the pod and to the back.
Because the Hyperloop is moving so fast, we need to be able to pull air from the front of it to avoid the Kantrowitz limit, as explained in the video on our channel.
In the designing of the Hyperloop compressor system, we've looked at several different types of compressor systems. We've gone from axial compressors to centrifugal to the one that we finally concluded with is reciprocating compressors.
Which basically what it does is it acts just like a car engine where the piston comes up, air is sucked in, the piston goes down, air is pushed out.
That it takes in all the air, it pressurizes it to the desired pressure, and then it moves it to a tank where all the air is stored until the tank is full. And then the compressor stops working and the outlet of the tank opens up so the air can exit the tank.
We're moving at, in this testing scenario, 85 meters per second, which is too fast for a lot of compressor systems to handle. So we control this air. And we intake it, we compress it, and we supply it to the various subsystems within the Hyperloop pod.
It needs to be able to provide air to the air bearings, which will allow us to have a near frictionless suspension system, allowing for super fast travel.
We have been able to find a way that allows us to build a relatively well-priced compressor system and be able to utilize that and the reciprocating nature of how they compress air and create a system that is much cheaper than any of the alternatives that we have seen that we can currently build.
Which allows us to reduce the cost, reduce the power requirements, reduce the safety factor required, and generally give a more secure package that will allow us to overcome the same obstacles. So it's using less resources to do more.
We've gone through all of these different designs. We've gone from axial to centrifugal to finally reciprocating. But also, like, the price tag has come down as well. From the original with axial, we were looking at about a $2 million price tag for something that would be the optimal solution for this Hyperloop pod.
Our design is unique because it's a significant departure from Elon Musk's original design, which required 2 axial compressors.
Most Hyperloop teams, and what was suggested in the white paper, is actually looking for either a centrifugal or an axial compressor, kind of like what you find in a jet engine. So starting from day one, this was a very challenging obstacle. There's a reason why this is a white paper that's been sent out to the entire world. And even then, so few teams have been able to make it through the competition thus far.
Most of the designs were very expensive. Not to mention that some of the parts or motors that we needed to have within our system did not exist in real life.
We then also looked at various ways of modifying either centrifugal or axial compressors. But all the ways we tried were either required too much cooling and required varied amounts of airflow and compressor chaining.
Spinning a giant jet engine it takes a lot of power.
Cost is a huge one. It drove us away from our original design to this much more affordable design. And power is another one. The original design would have required motors with large amounts of power, which would have been prohibitive for the pod without the use of fuel, which would have defeated the purpose of the Hyperloop pod.
This team is just supremely qualified to be the compressor team because we just have so many different types of people that are just overtly excited to do what we're doing.
Most of us have previously worked together for about 6 months on a separate project, so we understand each other well.
We have 7.5 years of experience combined in the industry. We've worked in numerous companies all around the world. We've dealt with different types of projects that involve machinery, construction, research and development.
Our team fits really well together, so it's not just that we have these discrete experiences, but also that we're greater than the sum of our parts, and that we have this really intense drive to win this competition.
Make sure to follow us on Twitter, like us on Facebook, subscribe to our channel, and support us on GoFundMe.